So today we are solving Leetcode 1128 problem number, and the question is saying that the number of equivalent dominoes pairs. Okay, and it is a very popular question that looks simple but needs a smart trick to solve efficiently. Okay, so you just pause this video and read this statement so you will be understand clearly. Okay, so the question is saying that we have given a list of domino at I is A and B is equivalent to domino at J, C, D if and only if either A is equal to B and B is equal to A equal to C and B is equal to D, or A equal to D and B equal to C. That is, one domino can be rotated to be equal to the another domino, and we have to return the number of such pairs. Okay, and like this is the example we have given. Okay, so we have to understand how this example works and why it is saying that to find the equivalent or what is equivalent, right? So if you are preparing for interview and this kind of pattern recognizes and hashing tricks is a gold. So let's dive in the coding. Okay, so first of all we should go with the intuition to understand the problem statement. Okay, so what the question is saying that you are given a list of dominoes and each domino has two numbers like A and B. So two dominoes are equivalent, considered equivalent if they are same when rotated. It means 1 and 2 is the same as 2 1, right? And so I have written here dominoes A and B and A are considered the same. So we need a way to normalize each domino in unique form. So for example, let's understand both 1 comma 2 and 2 comma 1 means 1 2 and 2 1 will become the key 1 2 or 2 1. Either you write 1 2 key or 2 1, depends on the sorting. So we'll use the frequency map to count how many times each normalized domino appears and then use the formula, right? So what is the formula here? So number of pairs from n same item is n into n minus 1 by 2, right? Mathematically you know that, right? If you find the count and you know the patterns, right? So you can use the formula and you can write it. Okay, so our job is to count how many pairs of dominoes are equivalent, right? So if you talk about the question, what is the question is asking? Okay, what is the problem asking to us? So problem is saying that the dominoes are equivalent if they are exactly the same, even if one is rotated. Means, for example, the example first that we are talking about 1 2 2 1 3 4 5 6, right? So 1 2 is equal to 2 1, but 1 2 is not equal to 3 4, is not equal to 5 6, right? Means we can say 1 2 is equal to 2 1, and so this pair of dominoes is equivalent, right? And 1 2 is not equal to 3 4, and so this pair is not equivalent. You understand, right? So the array that you have given, in that lot of elements are there, right? So you have to check this pair is equivalent to this pair, yes or no? Yes, right? Is this pair is equivalent to this pair? No. Is this pair equal to this pair? No. Is this pair equal to this pair? No. Is this pair equal to anyone? No. Means there is only one pair, this and this, and so this pair of dominoes is equivalent. You got the point, right? So let's understand how. Okay, so if we have another example where we will use 1 2 1 2, right? Then we'll take 1 1 1 2 and 2 2, right? So let's normalize this form and understand. If we'll talk about 1 2, the key is 1 2, 1 2 the key is 1 2, 1 1 the key is 1 1, 2 1 the key is 1 2, and 2 2 the key is 2 2, right? So as you can see, 1 2 we have key 1 1 1 2, and 1 2 we have key 1 1 2 1 2, and here's 1 2. right? So now how many times 1 2 appears? So 3 times, right? How many times? 3 times. And how many ways can we pick the pair from 3 same item? So how many ways we can try? So we can use the formula 3 in, because 3n, how many times? 3. So we can say n into n minus 1 by 2, right? So 3 into 2 by 2. So we can divide 2 by 2 and so it becomes 3. And so the answer is 3 pairs. Okay. I hope you understand, right? You pause this video, go through this example, right? Or the previous example, you will understand what I'm trying to say here. Okay. So if we'll talk about the final goal, what is our final goal? So final goal we have to return how many equivalent domino pairs are in this input. Okay. And that we have to return it. You gotcha, right? So here is the trick. Here is the trick. What is the trick? Since A and B is same as B and A, we need to normalize them, right? So we'll always store them as a 2-digit numbers, right? And so the key will become what? 10 into mean of A comma B plus max A comma B. This example tells everything. Okay. So understand how we are going to solve it, right? So we'll talk about this that I was talking about. Okay. So the approach is, first we will initialize an array and we'll say it count, right? And we'll store all the frequencies of the incoming pairs, right? And why the size is 100? Because the max value with a 2-digit is 9 into 10 plus 9, it becomes 99, right? So for each domino, we'll say A comma B, right? For each domino, A comma B is same as B comma A. So we need to normalize this. So how we'll compute the normalization, right? So the key is, the normalized key is 10 into minimum of A and B plus max of A comma B. So if you apply this formula, you will get the normalization, right? If you want to normalize this, so you will get the normalized key also. Okay. So you can find like this. Okay. So for each domino, we have to add the current count of the key to the result, right? For each domino, you will add to the count, right? And you will return it, right? After that, increment the count of this key and will return the result, right? So both, let's suppose 1 2 and 2 1 will become what? 1 2, because if you apply this normalized formula, 10 into mean A comma B plus max A B. So there is a 10, minimum of 1 2 is 1, max of A 1 2 is 2. So there is 1 and 2 will get multiplies with 1 and we are adding 2. So it becomes 12, right? You got the formula, right? So you just put A as 1, B as 2 and you apply, you will get 1 2, right? So 1 2 will become the normalized key for the inputs. Okay. So in this way, first of all, we'll initialize. What I'm trying to say in this approach is, first of all, how we solve it, right? So first of all, we'll initialize a count array of size 100. Since the max size is 2-digit key 99, then we will loop through all the dominoes, and for each dominoes, what we will do, we'll compute the normalized key with the help of this, and then we'll add the count of that key to the result, and then we'll increase the count for future pairs. So this way, for every domino, we are counting how many times we have seen as an equivalent one or earlier, right? And so we will return the result. Let's understand the coding part, right? So let's suppose we have given these inputs in the example, right? So in this example, we are saying this is a 2D array, right? And dominoes are 2D array because it contains in the pairs, right? Whenever a single element in array is getting called as a pair, means it is a 2D. Okay. And so will take 100 as we have discussed, because the size because the key range, you can say, is 99 to till the 99, 11 to 99. Okay, and so the result will take 0 in starting and will return it here. Okay, and before that we'll do the for each, right, and we'll compute the normalized key, right. How we'll do that? So we'll take a domino at 0, b at domino at 1. We'll find the normalized key as key if a is less than b. We'll say a into 10 plus b or b into 10 plus a. You will get the normalized key, right? Or you can directly apply that formula, you will get the result. And then result plus equal to count key, right, will keep updating, right. So the count at the key you will get from each earlier occurrence, right, and you will keep updating here, right. So the result will get updated, you will get the count at that key. So let's suppose 3 times it is coming, so you will get the 3 times, right, and at that key. And so the you have to count that key, and then you will do what? Count at key plus plus, you will keep updating the key, right, how many counts are there, and finally you will return the result. Okay, so in this way you will return the all the number of equivalent pairs, right, because all the pairs you are counting in the result set, a result you can say, and it will return. So this code will runs in O of n times, because we are going with all the dominoes for each we are making for, and for due to the for each you are traveling to all the elements, so it will take O of n times, and it will use the constant space, since dominoes values are limited to 1 to 9 and is super efficient for the constant, because it is less than constant n is less than equal to, let's suppose, of around 40,000 it will come, right. And so that's all for today. So let me know guys if you understand this problem, and please ping in the comment box, do you like this video or not, if in this way you are liking the code or not, right. So that helps me in improving the videos, and that's all for today. So this is a great example, right, because we have done a lot of things, right. And so if you want to do dry run, right, so what you have to do? Okay, so you go through the you write the one column as a domino, right, and put all dominoes. So dominoes for 1 2 is key is 1 2, 2 1 is 1 2, and 3 4 is 3 4, and 5 6 is 5 6, right. You will do the count, right. How will you do the count? So before count it is 0, now the key is already 1 in the count, so you will say count is 1, right. Next time it is coming 12, right, so you can check in the count, yeah, before it was 0, now it is 1. Okay, so total pair you will check, so total pair is coming 1, right. So like that you have to implement the code, you can try to run the code, and this is the approach that we have talked about, right. So pause this video again and try to implement by yourself, right. So this will help you to implement. Okay, so please like this video, subscribe for more DSA videos and Leetcode problems. Drop your next problem in the comment guys, and thanks for watching and happy coding.